Michael Feathers' seam model solves a real problem. How do you add tests to code that wasn't designed to be tested? Most teams think they need massive refactoring first, but there's a surgical approach. By the end, you'll know what seams are, how they break the testing catch-22, and specifically how to use object seams, the most common type. This is practical guidance for the modernization patterns teams actually encounter. The beauty? You introduce testability exactly where you need it, without rewriting everything at once. Here's the classic problem. You've got a class that directly instantiates its dependencies, creating a new payment gateway on the spot. When you try to write a unit test for process order, there's no way to substitute a mock. Every test hits the real payment system. You can't run tests in isolation, can't run them fast, and you might actually charge real credit cards in your test suite. The catch-22 is brutal. You need tests before refactoring safely, but the code structure prevents testing. Most teams assume they need architectural overhaul, but there's a surgical approach. Feathers nailed the definition. A seam is a place where you can alter behavior without editing in that place. Read that again. Without editing in that place, you're not touching the problematic production code. Instead, you change what happens at that spot by making a decision somewhere else entirely. That somewhere else is the enabling point, where you control which behavior gets executed. In our payment example, the seam is where order processor gets its dependency, and the enabling point is your test setup where you inject a mock instead of the real thing. Every seam has two parts working together. The seam itself is where behavior actually varies in your code. The enabling point is where you decide which behavior gets used. Think of a light switch. The seam is the bulb socket where light happens, but the enabling point is the switch on the wall where you control it. In that order processor example, the seam is where the payment dependency gets used, but the enabling point is way over in your test setup where you're deciding to inject a mock instead of the real gateway. Object seams are by far the most common type you'll encounter. The transformation is straightforward. Take that hard-coded dependency, literally newing up payment gateway right inside the method, and pull it out to the constructor. Now the seam is that payment property. The enabling point is wherever you construct your order processor. In production, you pass in the real gateway. In tests, you slip in a mock. Same code, different behavior, zero edits to process order itself. This works beautifully with refactoring tools and maintains type safety. In production, you pass in the real payment gateway, nothing fancy. But in tests, that's where the magic happens. Create your mock, inject it through that same constructor, and you've got complete control. You can verify the charge was called, check what amount was passed, even simulate failures, all without touching process orders implementation. This is what altering behavior without editing in that place looks like. The enabling point, that constructor call, does all the heavy lifting. Same method, totally different behavior depending on what you inject. Feathers identifies three distinct types of seams, and they're not created equal. Object seams, using polymorphism and dependency injection, are your go-to in modern languages. That constructor or DI container is your enabling point. Link seams work at build time, swapping entire modules through build configuration, useful for JavaScript or C++ libraries. Preprocessing seams use #ifdef with compiler flags. These are actually recommended as a last resort, mainly for legacy C and C++, where you don't have better options. Object seams first, link seams second, preprocessing only when stuck with old-school compiled languages. Here's the classic time testing problem. Code that checks if something's expired by calling getCurrentTime, but you need to control what now means in tests. With a link seam, you create two modules with identical exports. One returns actual current time for production, the other returns a fixed date for tests. Your build system becomes the enabling point. It decides which time provider module gets linked. Notice zero changes to the isExpired function itself. That's the whole point. Behavior varies based on what gets linked in, not based on editing that code. This works beautifully where module systems give you this flexibility. The extract and interface pattern is the most practical way to create object seams. Start by identifying that hard-coded dependency. Here, it's a static database call, making testing impossible. Then extract an interface defining what operations you need, just the save method here. Finally, inject that interface through the constructor, and you've created your seam. The enabling point is wherever you construct user service. In production, you pass the real database. In tests, you pass a mock. This three-step process works in Java, C#, TypeScript, really any object-oriented language. Most IDEs can even automate parts of it. When should you actually use seams? Use them when you're stuck in that catch-22. You need tests to refactor safely, but the code is untestable. They're perfect for mocking hard-coded dependencies or migrating legacy systems incrementally. But here's what's crucial. If you're writing new code, just use proper dependency injection from the start. And remember, seams are often temporary stepping stones toward cleaner architecture. Once you have test coverage, you can refactor more confidently and potentially eliminate the seam altogether. They're scaffolding, not the final building. Let's look at real-world problems where seams save you. That logger.get instance. Call littering your codebase? Extract an iLogger interface and inject the instance. Suddenly tests can verify logging without touching the file system. Static database query. Calls making your test suite crawl? Inject an iDatabase connection and swap in an in-memory implementation. Time-dependent code using newDate directly? An iClock interface with a nows method lets you control time in tests, and those flaky HTTP calls to third-party APIs? Extract IAPA client, use a mock, and your tests run offline with predictable responses every time. Seams are your surgical tool when working without a safety net. No tests, high risk, tight deadlines. They're stepping stones, not the destination. But if you've already got test coverage, or the code is low risk to rewrite, skip the seam and go straight to proper dependency injection. Use seams surgically. Add them exactly where you need to break dependencies, then move on. Don't seam everything just because you can. Sometimes full refactoring is the right answer when you have the safety and time to do it properly. Here's your practical path forward. Identify that one hard dependency blocking test, maybe a static database call or singleton logger. Extract an interface to create your object seam. Now here's the magic. Write characterization tests using mocks at that seam. This breaks the catch-22. You've got tests without massive refactoring. Once you have that test coverage, you can confidently refactor toward better design. The seam was your stepping stone, not your destination. This is how you escape the testing trap and start improving legacy code incrementally. Pick one untestable class, maybe something with a static database call or singleton logger. Extract an interface, inject it through the constructor, and you've got your object seam. Now write that first characterization test with a mock. Object seams are your best tool in modern OO languages because the enabling point, where you construct the object, gives you complete control. Start with just one class, prove the technique works, then expand. Chapter 4 of Working Effectively with Legacy Code has deeper examples. Next, we'll explore how Martin Fowler extended the seam concept to the strangler fig pattern for migrating entire legacy systems. If this helped you break the testing catch-22, subscribe for more practical modernization patterns.